Hey guys, I hope you are ready to start your last chapter of calculus. This chapter focuses on applications of integration. Last chapter was all applications of derivatives. This one is now applications of integrals. Let's get right to it. Sketch the region bounded by the graphs of the equations and find the area of the region. Now, even if it didn't tell me to sketch the graphs, I need to in order to do the integrals. So let's go ahead and do that. That was awful. Try that again. A little better. I confess, these are hard to do without a calculator, and usually these questions show up on the calculator portion of the AP exam. So I might take a peek and see what negative x cubed plus 2 looks like. I'm not going for anything exact here, I just need a nice rough sketch of that. X minus 3 should be a linear line about here. And then x sub 1 equals negative 1 and x sub 2 equals 1. This is just giving me regions here. I've got x equals negative 1 and x equals 1. And so the point of this was to sketch the region bounded by the graphs. So I'm looking for what area was enclosed by all of this. And what I see is this region right in here. I want to find the area of that region. And so the way these work is if I were to integrate, I'm going to undo what I just did there. If I were to integrate this top function, I would find this entire area under it. And then if I were to integrate the bottom function, I would get this area underneath it. And what I want to do is I want to subtract those areas. I'm just interested in the difference right here. And so that's exactly how these work. I take the integral of the top function minus the integral of the bottom function. And so even if the question didn't tell me to sketch the region bound by the graphs, I need to sketch it so that I can clearly decide which of these functions is the top, which of these functions is the bottom. Once I've decided that, then the integral is pretty straightforward. I'm going to integrate just from my x boundaries, so from negative 1 to 1, of the top function minus the bottom function. All of that with respect to x. And the thing I'm paying attention to here is that I distribute that negative through these parentheses. That's where you're most likely to make a mistake. I can go ahead and simplify that. Let's say that's from negative 1 to 1 of negative x cubed minus x. And this term here becomes positive 3. So I have positive 2 plus 3 plus 5. And then I can integrate that. And I evaluate it from negative 1 to 1. And those fractions get a little bit tedious, but that's okay. Have negative 1 to the 4th over 4 plus 1 squared plus 5 minus my lower limit. And I'll go ahead and distribute this negative, see what happens here. I've got negative 1/4 plus 1/2 plus 5. That becomes plus 1/4 minus 1/2 and plus 5. And that's worked out nicely. 1/4 cancel out, 1/2 cancel out, and I've got 5 plus 5 gives me a final answer of 10. Not too bad. Let's look at the next one. Find the area between the curves, and you'll notice here that it doesn't give me any boundaries. I don't have any x coordinates that I'm bound between. So let's take a look at the picture and see what's going on. When I graph this, I am not doing a good job of drawing axes today. If I graph this function here, it looks basically like this. Pretend that that is symmetric. And then y equals 0 is just my horizontal axis, right? And so the area that is enclosed by those two curves is here. And what you see happens is that the top function changes halfway through the problem. It starts out that y2 is on top, but then at this dividing line, y equals 0 switches to being the top function. So what this means is I just have to break up the problem into two separate integrals. I'll find the integral of this section and add it to the integral of this section, where I switch my top and my bottom functions. So let's set that up. For the first section, I'm just going to integrate from -1 to 0, where the 3x cubed minus x was on top, minus 0 for the function on the bottom. And I'm going to add to that the integral from 0 to 1, where I switch those now. 0 is on top, and 3x cubed minus x is on the bottom. It should be a dx, kind of ran out of room there. I can simplify these integrals. That 0 was there just for show. I can get rid of that before I integrate. We'll go ahead and distribute the 3. So I have 3x cubed minus 3x dx. And then plus the integral from 0 to 1 of negative 3x cubed plus 3x dx. Once you've set up the integrals, you're done with the hard part. You're just integrating just like we always have. When I go to integrate that, I will get 3x to the 4th over 4 minus 3x squared over 2, evaluated from -1 to 0, plus the second integral gives me negative 3x to the 4th over 4, plus 3x squared over 2 from 0 to 1. It's very tempting to try to cancel terms out at this point, but don't do it because your limits of integration are different. I've just got to go through the tedious part and evaluate it. So when I plug in 0, I've got 0 minus 0 minus, when I plug in -1, that becomes 3/4 actually. Plus 3/2. And then for my second integral, -3/4 and 3/2 minus 0, that's convenient. I need some common denominators here. Well, let's see, I've got -6/4 plus 6/2. And I keep simplifying these fractions. I end up with 6 over 4 or 3 over 2. That is done.